Hello, today I'm going to be covering ratios and proportions. So for our agenda, I have to go over what ratios are, show you some examples, and then we'll talk about proportions. So let's begin with ratios. Now ratios are famously known as fractions, such as a divided by b, assuming that a is any real number and b is any real number. Now if we take a step back in our probability unit, we looked at ratios, but from a percentage perspective. In probability, we wanted percentages because they were good indicators, and those indicators gave us useful predictions. Now, in this unit, similarity in right triangle trigonometry, we're going to prefer the ratios. So we're going to prefer this, and in some cases, we're going to want the decimals. So we're going to shy away from percentages because in this unit, we want to compare quantities, not necessarily get an indication of whether or not we are making an optimal choice. So let's begin with some definitions. So what is a ratio? Formally, a ratio compares two numbers by division. They can be written as a to b, a with this two dots, b, and of course the one you've probably seen a million times, a divided by b. Now all of these are good with the exception that b cannot be equal to 0. So here the denominator can never be 0. Now in order to see how we can compare two numbers by division, I'm actually going to zoom in on this notation here. And let's take a look at an example. So example 1, let's get the ratios of boys to girls in the class. So assume this is the roster, and this indicates a boy, this indicates a girl. So here we see that we have 1, 2, 3, 4, 5. So we have 5 boys, and we're going to compare that to 1, 2, 3, 4, 5, 6, 7. So our ratio is 5 to 7, 5 boys to 7 girls. Here we're comparing two quantities. Now notice if I did 5 over 7, and if I get the percentage, I would get about 71%. But 71% of boys to girls in the class, this form becomes clumsy when we want to compare two things. So that's why we're going to, again, shy away from the percentage and use this form because this is more explicit when we want to compare two things. Let's take a look at another example. We can actually extend this to comparing more than two items, such as in this example, we're comparing three things: milk, grams of protein, and ice cubes. So suppose you're a bodybuilder and you're trying to maximize the amount of muscle you can put on your body. So you take into consideration protein shakes, and you check out this recipe right here. In order to make this shake, the recipe requires you to get 8 ounces of milk, and for every 8 ounces, you're going to have to use 25 grams of protein. And in order to make this into a good shake, you're going to have to put in 5 ice cubes. Now let's say that one of your friends is also interested in going through that bodybuilding route, and let's say you guys go work out together, or girls, and then you say, hey, I have this really good protein shake recipe, and you would like to share it. So you make it, but now you're gonna have to make two quantities, so you're gonna have to multiply this by 2. So now you would have to use 16 ounces of milk, 50 grams of protein, and you're going to use 10 ice cubes. This ratio now will provide 2 servings, and this one is for 1 serving. This example shows the power of ratios. Again, percentages are awesome, but we're going to stay away from them for a bit and instead focus on using these comparisons in order to reduce and scale things. So try out the next set of examples, and I'll see you back for example 3.